All right, I think we're going to get started. My name is Michael Weiss-Malik. I'm an engineering director on Google Maps.
And my name's Andrew Lookingbill. I'm one of the founding engineers on Project Ground Truth.
And we're here to talk about ground truth, accurate maps by algorithms and elbow grease. So first off, I'm a big fan of data. Google's a big fan of data, and we like to visualize data. So this is data on the presentation. This is the content of the presentation. We are intending to spend a little bit of time on what ground truth is, a little bit of time on why ground truth is, a bunch of time on how we actually do ground truth, and that's really the meat of the presentation. How is it that we make maps? And finally, we'll wrap up with a little bit of where we have done ground truth so far. So first, let's focus on the what. So what is ground truth? This is a little wordy, but it says it exactly right. A project to create accurate and comprehensive map data by conflating multiple inputs by algorithms and elbow grease. And that's really wordy, but we are going to break it down. And the first thing is, what is map data? You know, what are we actually talking about when we talk about a project to make good map data? Well, for purposes of this talk, we're going to define map data as the vectors on the map. This is basically everything you see on Google Maps that isn't an image. It's the roads, it's the postal codes, it's stuff that you don't see, like speed limits, city boundaries, everything that makes directions work, search work, all of that data, that's the data that we're talking about creating. So, having answered what is map data, there's actually a bigger question. What is Google Maps? Because the reason for ground truth has to do with a whole ecosystem of considerations. So to answer that, we're going to go on a slight segue. Let's pretend that map data is stored as movie film, just to make a really simple analogy, okay? If you define it that way, basically the way that Google Maps has traditionally displayed map data is we've had a data provider who went and took measurements of the world using, here through the analogy, a movie camera, and created that film that they then tossed over a line to us. So there's the data provider on one side and Google on the other. So what do we do with the film? We project it onto a screen. In this case, it's a drive-through screen or your laptop screen or whatever. But this is the traditional ecosystem. A data provider sits on one side of the line. They collect the data. They toss it over to us. And we take care of distributing it to users. Another way to look at this is actually it's similar to a movie rental store. So basically, you know, we have to go and pick out what titles are available. And the arrangement suffered from the same problems that, you know, old VHS rental stores suffered from. The selection was limited. The movie studios weren't necessarily making the movie that you wanted to make. They were, you know, you had to pick from what it was that they were interested in. And of course, the movie studio didn't like it very much if you edited the movie before you returned it back. So, you know, all these considerations, this gets us back to what is ground truth. Ground truth is a completely different ecosystem for producing movies. Basically, instead of this rental model and this model where there's a data provider on one side of the line and we're on the other, we've now become a movie production studio. We are making our own maps, hence the graphic at the beginning of the presentation. So that covers the what of ground truth. We're making maps. We're making Google Maps, Google Map data. Why? Why would we want to do this? So this is motivated actually by a couple of considerations, not just the inconvenience of the rental model, but actually all the data that we had lying around. This is some really cool high-resolution aerial imagery of some backyards. And I'm from Phoenix, so I immediately recognize in this. At the top of there is a tiny little hose in a pool. That's actually an automatic pool cleaner hose. It's literally the size of my wrist. We can spot this stuff from the air now. And that's nice and that's good eye candy, but what it really means is that when we look at roads, we can spot the roads from imagery and accurately map them. We can accurately map where you can turn, where you can't turn. You can literally trace out a map. And so a lot of the impetus from this came from the fact that Google had so much data inside that we thought we could leverage to make good map data. And of course, we have Street View as well. From Street View, we get a tremendous amount of mapping information. We can see one-way streets, we can see bicycle lanes, types of roadways, you can confirm street names, you can confirm address numbers, you can even extract business logos. And as we'll get to a little later, we can do a lot of this autonomously. We can actually automatically recognize numbers in Street View imagery and run some algorithms on them, and out the other end pop millions of addresses that we've actually created in Google Maps purely from Street View imagery and computer vision algorithms. So why, it's not just enough to have the data. Why do we actually want to go through all of this effort? And it basically amounts to it benefits our users, and there's a couple different benefits that it offers. The first is that through this process, we wind up working directly with authoritative data providers. In the movie analogy, we're dictating the actors. We're not going through a studio. So we get to pick, if we want to talk to a postal service or a national park service, we work directly with them and get the best data that can be had. We also get to match our investment to our user needs. Google's a very global company. We have users in a lot of different countries. Map data providers may or may not be investing in the same places that we really want to invest. So this lets us match up to our users much, much better. And then lastly, speed, speed, speed. This is a big theme of ground truth. We do things quickly, and it enables Google to do a lot of things quickly. We want to be able to publish updates to the map. We want to be able to accept updates to the map. And the only way to really do that on a tight cycle is if you own the entire map production. Because previously, if you had to report a problem with, say, the map data in the US, you'd have to go to one of our data providers, wait 6 to 18 months and hope that they actually fix it, and then they'd have to send the data to us, and then we'd have to publish it. Now, since we own the data, we own the whole ecosystem, we can actually publish that update immediately, and you can come directly to us for that. So that's the what ground truth is. That's the why we did it. Now we're going to get to the meat of the presentation, which is how it actually works, which I keep hand waving. So ground truth is basically 3 pieces stacked on top of each other. The first, as I've kind of already talked about, is authoritative data. We go directly to postal services, we go directly to governments, we go directly to really well-known map providers themselves, and we get the data directly from them. We work out arrangements where we can absorb that data directly. We combine that with internal data that Google has. This is one of the best leverages that we have because we're one of the few companies that has all this satellite and aerial imagery and all this street view imagery. And you can conflate those two together and correct one with the other. So even though you got, say, your roads from the city, it turns out when you look at road data and you compare it to satellite imagery, it doesn't always line up so great. So you can correct the road imagery and make it even more accurate by snapping it to what you see in the satellite imagery. Then the last chunk is algorithms and elbow grease, the byline of the talk. This is actually where the meat of everything happens, and this is what we're going to demo. We apply a variety of stages of work where we take the raw data that we got from the provider and we clean it up successively. For example, we actually take the streets that they gave us and we drag them manually to match all of the roads that we see in satellite imagery. So there's a variety of manual processes that go on, as well as a bunch of automated algorithms like the computer vision that I mentioned from Street View. And we go through successive stages of work where we clean up different aspects of the data, and out the other end pops a map that is higher quality than the sum of its inputs. So we're really going to focus on this algorithms and elbow grease part. And to accomplish the algorithms and elbow grease part, we built a tool internally called Atlas. And this is a screenshot from Atlas. It's fully homegrown. It's unfortunately internal only. You're going to get to see some of it, but you don't get to use it. It's actually used by a team of what we call operators, ground truth operators. And this is a dedicated internal workforce that goes through a huge amount of training on policies, procedures, and the tool itself, so that they know how best to implement the policies that we've come up with that result in a high-quality map. It's worth noting we're going to demonstrate a whole lot of the elbow grease because basically algorithms are really boring to demo. It's no fun if we hit a button and all of a sudden there's a name on a street. So that's less visual. It's more fun to work on sometimes, but we're just going to show some of the manual stuff. So with that, I'm going to hand it over to Andrew and see if the video setup here works.
Hi. So this is Atlas, the in-house mapping tool we developed. I'm biased, but it's actually my favorite client for consuming Street View and satellite data. In addition to what we have published on maps.google.com, where we have sub-meter resolution imagery for 75% of the population, we also have access to assets that we don't necessarily publish, either for age or aesthetic reasons. This allows us to track changes to an area over time. We can also cleanly overlay vector data, comparing one against the other. We also, in the tool, have access to the 5 million miles of driven Street View data, 3,000 cities in 50 countries. And again, even when immersed in a panorama, you can cleanly overlay vector data. This is important for maintaining spatial context. Similar to the smooth transitions into and out of the Street View imagery, this isn't just eye candy. It increases productivity because ground truth operators don't need to pause to reorient themselves. Finally, you're looking at an internal-only fisheye viewer that we can use even in the top-down mode to quickly select a panorama of interest. Next. Now, sometimes when the source data comes to us, it's in pretty rough form. This is actually Tiger Road data, the free public domain data set we started with in the US. And if you look at it paired over satellite imagery, you can spot some problems. Not only are there alignment issues, but there are also occasional connectivity problems. For this reason, the first step that a ground truth operator takes is to actually bring the geometry into alignment with satellite imagery. They can drag intersections to deform entire sections of the road network at once, and then replace existing geometry with new vertices. One of the reasons we do this, instead of creating the road network from scratch, which with our tools might be even faster, is that in this way we maintain attributes of the data such as names, address ranges, speed limits, etc. Now, even geometry editing actually requires a decent amount of policy and a deep understanding of how to model road networks. For example, here, we're splitting a road into its left and right halves, but doing so creates a number of new intersections that also require careful handling and policy. Now, treating these details consistently across a country allows our products, like driving directions, et cetera, to behave consistently across a country worth of data. And this is one of the reasons why operators require a good deal of training before they're fully proficient. It's also critical for Project Ground Truth that we get every turn restriction for every intersection correct. An example of a turn restriction, for instance, is not being allowed to turn left at a given stoplight, or perhaps not being allowed to make a U-turn on a given segment. Now, here in the tool you can see if you enter along the yellow arrow, you can exit along any one of the green arrows, but not along the red arrow. Editing this complex data can be tricky. In Atlas, we streamline the process by providing a set of keyboard shortcuts that allow an operator to quickly hop between all of the various entrances and exits from an intersection, perfecting the turn restrictions. They're often able to do this based on the pavement markings they see in aerial imagery, but we also heavily rely on integration with Street View. In fact, they can even make annotations such as this one, clipping a sign to kind of leave a trace of what they were looking at when they made a decision. In fact, these clipped annotations are even visible in the top-down view, correctly oriented to speed the work of people who come after. Although in this situation, we've chosen to focus on an manual extraction of a piece of information from the Street View imagery, we actually have computer vision algorithms that do a fantastic job of extracting a number of road signs, as you'll see along the southern part of this road. So, you have a number of people editing very complex data concurrently. You start to worry about data consistency. What you need is a smart, automated system that suggests when possible errors might exist in the data, sort of like compiler warnings that might warrant a human second check. In fact, in this case, we use the same anonymized traffic data on maps.google.com to suggest that, in fact, what we have modeled in our data as a two-way road might, in fact, be a one-way road. An operator claims the issue and uses the available tools and the Street View and satellite imagery to determine that, yes, in fact, this road should be one way. They update the vector data and move along, but if they had claimed this issue and decided that it was a false positive, they would have resolved the issue in such a way that that same issue would never flag on that same data again in the future. Now, sometimes the data we take in has strange, consistent islands of error. For instance, an entire neighborhood worth of roads might be offset by 1,000 feet, or there might be consistent errors with scale or rotation. Correcting these one at a time would be cumbersome. Luckily, we have a few bulk transform tools, such as the one you see here. An operator defines the area over which they want the transform to take effect, and then begins defining pairs of control points. Each pair of control points says that this point on the road network corresponds to this point on the ground. An operator can see a preview of the transform vectors and then continue to add pairs of control points until they're satisfied with the warp. After they're satisfied that the warp is going to do what they expect, they can choose to preview the warp and then hit save, which will actually bulk transform all of the data at once.
So, as you saw, these are a couple of the different kinds of stages of work that we go through where we clean up different aspects of the data. There's other stages where we look at freeway signs and get the freeway text. We look at speed limits. We look at road type, distinguish highways from local roads. And at the end, so on the left is what we started with. Andrew mentioned Tiger. This is actually a public domain set for the US put out by the Census Bureau. Census Bureau cares about counting houses. They don't care so much about freeway off-ramps, so it's kind of a disaster on the left. After many, many stages of cleanup from us, on the right is what results for the ground truth data. One other example, a little more zoomed in, this is actually just around the corner from Google's Mountain View campus. Again, on the left, there's a freeway interchange, and everything's just modeled wrong. The connectivity is wrong. The alignment is terrible. We go in, we clean it up stage after stage, and out the other end pops polished data. So that takes care of what, why, how. Now we thought we'd talk a little bit about where we've done this. So in a nutshell, Brian McClendon, and during the keynote this morning, actually talked about this a bit. The green countries here are where we've done ground truth. We've done it in 43 countries and regions. They launched over the past 5 years. This is a ridiculous rate of speed for mapping, actually. We're quite proud of it, and in these 9 separate launches that are detailed below. So it's been a long effort and a lot of work, actually. So the natural question that I get whenever I show this is, where are we going to map next? And this is probably the most frequently asked question, and unfortunately the answer is silence and crickets. We don't like to speculate about future products and services. What I can say, though, is that this is an incredibly efficient mapping machine that we've built. We're not about to turn it off. We do want to map more, and these will not be the last of the countries that you hear of. So in theory, that takes us through what, why, how, and where, but you get a little bonus. We're going to talk about beyond ground truth and what happens after we initially publish the data. The biggest challenge for any map maker is that as soon as you publish a map, it's out of date. By fixing it in any kind of solid form, the world is changing, the fixed form is not. So the world is updating, the map has to update. So the story doesn't end with the mapping for the first time. You have to map for the rest of time. One of our main mechanisms is something that we call report a problem. Users can click a link in the lower right corner of the map. It also appears in a few other spots in the UI. And they're taken to a dialog flow that lets them submit any type of problem. You can tell us that your house is in the wrong place. You can tell us that your city is named wrong. You can tell us that street has a wrong name. And you submit that, and the same operators basically that do mapping, some of them have been trained on how to receive these reports. And we receive several thousands of these every day, and we process them manually and get back to you. Additionally, that's desktop. You can also do this on mobile. On iOS, if you have the Google Maps app, at any point in the app, you just shake it, and it vibrates and pops up a little, hey, do you want to send some feedback? And one of those feedback flows allows you to submit map data corrections the same way that desktop does. On Android, you can press and hold anywhere on the map and basically bring up a location pin, and then there's a report a problem link from there. Or in driving directions, the little more menu has a report a problem link. So you can tell us that you can't turn left here, or you can turn left here. Why isn't Google suggesting it? Now the fun part, of course, is that when you accept user reports, you accept anything and everything. This is an actual report that came in just after the launch of the US. There's a field of marijuana here. Please call the cops. We really do get anything and everything. This is somewhere in Michigan, I guess. But that's just how it goes. If you want to go a step beyond reporting a problem, you can actually fix the data directly yourself. We offer a product called Google MapMaker, mapmaker.google.com. It lets you directly edit the map data. It's kind of like the tool Atlas that Andrew has been demonstrating, but for the web. It's a web-based map editor. And when you submit edits on MapMaker, they go through a moderation system. So we, or a trusted external user, actually validates the edit that you suggest and confirms whether it conforms to all of our policies. So we're going to demo that a little bit.
Excellent. As Michael mentioned, we get thousands of reports every day. And the video we're about to show, hopefully, fingers crossed, is actually a life cycle for one of those reports. There we go. Actually, that's the indoor one. But
one second.
OK. At any rate, what you're actually going to see in the video is a user who asks for directions to a certain place, gets the directions back, and actually feels like telling us that, in fact, the left turn that they're directed to take isn't possible in reality. As a result, they try and report a problem. Now, using the interface that Michael just showed you, it's possible to select which exact step you think contains the problem. The report's then sent to a ground truth operator who uses all of the tools and the imagery that you've just seen discussed to decide whether or not the report has merit. If they decide that yes, in fact, the data needs to be updated, they make the changes, and as soon as it's saved, all of a sudden, other users aren't given data with that error. So that's the report a problem flow. The MapMaker one?
Yeah, we'll switch to MapMaker.
Excellent. Also, Michael mentioned MapMaker. Many of our users take all of the stuff we've discussed and want to take it a step further.
Sorry. We've got a bunch of different. Hang on one second. Something is not going right. Okay. That one's queued
Okay.
up for now, real quick.
Cool. So this is the report of problem flow I just mentioned. It's actually the left turn that seems problematic. You'll watch them report a problem. The nice thing is you can select the exact turn. That in turn helps the operator. The feedback goes to one of our ground truth operators. They use the tool, just as you've been seeing so far. They can look at the text as well as what they see in the area, the various state of the intersection and the turn restrictions we've been discussing, all of the overlaid vector data, and also the imagery to decide that, yes, in fact, this left turn shouldn't be allowed. They restrict it, and then the edit goes live.
And 1 second for MapMaker. Sorry, we're doing a
Okay.
backup presentation method here.
So, as we mentioned, a lot of users want to take this one step further, everything we've been talking about today. They want to actually edit the map data directly, leveraging their local expertise. And for that, as Michael mentioned, we have MapMaker. Here you actually see a video of a user who's familiar with a particular area. They're taking a road, and they're starting to update certain attributes of it, including the name, the speed limit, and whether or not it's paved. As the video goes on, you'll actually see them use the satellite imagery to perfect the geometry of the segment so that it exactly matches reality. Once they're done with their edit, they'll submit it for moderation, and once moderated, the change will go live within minutes on maps.google.com. It's a little long.
So it's very similar to Atlas editing, but it's in a web editor, so it's very accessible to the average user. So we'll cut that off there. Sorry about the technical difficulties. All right, and then the last topic that we want to talk about on that is indoor mapping, what we call the final frontier. And there was actually just a session on this, otherwise we would be telling you to go to it. But basically, it's not sufficient to map the outdoors. We want to be able to give you walking directions from your terminal at the airport when you land to your next gate, and all sorts of things like that. So we're going to, hopefully, have a demo video of that.
So, if you attended Sarah and Waleed's session on indoor mapping, you know that we're starting to bring the characteristic Google Maps experience to the interior of buildings as well.
Got it.
Ha.
Sorry.
So, in theory, this is just an extension of what we already know how to do as far as map data creation is concerned. Take data, iterate on it, and improve on it using our existing tools. In practice, however, there are a couple of problems with this. One of which being we can't actually do a good job of tracing indoor maps from satellite imagery because the roofs of the buildings get in the way. You can see an exact example of this. This is Terminal 2 for SFO. What's going on inside, we have no idea. Luckily, we have a few tricks up our sleeve as well. By partnering with building owners, we can acquire digital floor plan data. We can align this in Atlas to match with the building's footprint so that ground truth operators can begin the process of mapping and modeling things like security checkpoints, elevators, escalators, restrooms, changing stations, etc. Now, while in theory, this just requires a little extra tool work to make sure that we can visualize and edit things on multiple floors, and also cope with a feature density that's up to 3 orders of magnitude higher than for outdoor mapping, the rest of it's just business as usual. In fact, you see here that we even take pains to model the indoor road network. This corresponds to where you're allowed to walk or not walk inside the airport. And as a result, if you're using Google Maps for mobile, we can direct you to your connecting gate as soon as you step off the flight.
All right, so let's talk a little bit about what this all amounts to in terms of mapping at the speed of Google. You know, we get thousands of these reported problem submissions a day. Most of them are responded to actually within 24 to 48 hours. We don't backlog them, so we have to keep up. Most of the edits that result from these reports and from MapMaker go live within minutes of approval. I can't stress how amazing this is. You know, we have multiple data centers worldwide, multiple products. We have 1 million API websites. All of them get updated usually within minutes of most edits being accepted. So when we rename a road, it happens pretty quick. And additionally, all of that happens within the context of the rest of mapping at the speed of Google in terms of our products and services. Our tiles that are served for Google Maps, these are the images that load in blocks as the web page loads. They have an average of 75 milliseconds for their serving latency, which if you are techie at all is sort of mind-blowing at the scale that this is going on at. We maintain 4.5 nines of uptime over the last 3 years, which is really, really high. This actually means that if Google Maps is down, chances are it's your internet provider, not us. And at our peak, we have served 1.6 million queries per second. That's 1.6 million of those little tiles going out every second to users around the world. This stuff blows me away. We also accept updates from more than just our users. We've talked a lot about our user strategy here, but we go back to our authoritative sources. We do have arrangements with them where we refresh data. We also, of course, are redriving Street View on a regular basis. And in fact, some of those redrives happen in response to user issues. We do, in fact, go out and drive places where we need to clarify a mapping problem. And then satellite imagery and aerial imagery are constantly being refreshed. This is the other utterly amazing thing to me. Every 2 weeks, just every 2 weeks, Google publishes as much new imagery as all of Google had in 2006. That's how quickly we're updating the aerial and satellite imagery. So we regularly drop issues where we might not have a clear enough view of the intersection, and we go back then, when the imagery has updated and fix the problem. We also have this fun thing that we call internally called the Crystal Ball Report, and it's basically a system that we have for scanning social media and news sites, and we try to proactively identify issues that users are complaining about, but that they might not be sending directly our way, because it's also a source of information. So in some cases, we try to fix things before they become a story, and that's been very effective. So all of that amounts to a map of the world, and where is Google Maps at this point? We've talked a lot about ground truth, we've talked a little bit about MapMaker, but basically this is the present picture, and this was presented in the keynote this morning as well. Google has, as of recently, 200 countries mapped around the world. We finally got North Korea mapped. The video rental model that I spoke about in the beginning is still in play in quite a number of countries, and it is actually an important model for us. In some cases, it's what we prefer. Ground Truth has launched in 43 countries and regions. The most recent was Thailand and Indonesia just a few weeks ago. And then the blue countries are completely MapMaker sourced. And these are the countries where users are the ones that are generating the map, and we're just providing basically a platform for them to do so. It's also worth mentioning that many of the Ground Truth countries have MapMaker launched as well. So in the US, in the UK, in a number of other countries, you can directly edit the data. And it's our intention that wherever we do Ground Truth mapping, we do want to support MapMaker as a venue for users correcting the data. So that's about all we have for today. Thank you all for coming, and we'd be happy to take any questions.
Hi, my name is Thibaut. I work with a business software, and they usually have warehouses, and they don't want to put their indoor maps on the public internet. Is there a possibility to do indoor mapping for private locations?
So there is a product, Google Maps Engine will cover some of that use case. It's basically an online data store, but it's private. It's ACLed, with access restrictions, so that you can have private instances of a map and you can control who has access to it. And I believe there's probably sessions and probably some demos as well.
Can you repeat the name, please?
Google Maps Engine.
Okay, thanks.
One data source you didn't mention is the hundreds of millions of people walking around using Google Maps on their phones, and I would think you'd be able to, I don't know, track where they are and that you'd know those were real roads and real sidewalks. I mean, is that something you do, or why not if you don't?
So we do leverage anonymized traffic data for a lot of our mapping processes. Andrew demoed the one-way detection that we did, and that's one example of it, and there's other places in the data where we do try to leverage that.
Hi, can you go into a little bit more detail about computer vision that you utilize? I know you talked a little bit about like some sign detection and stuff, but I wasn't quite clear on whether you actually look at the street view or the satellite imagery and infer like the roads from the actual imagery, or and just a little bit more maybe about kind of the automation, because I know you wanted to talk more about the user interface, but if you could just go a little bit more into that.
Yeah, we have a wide mix of manual stuff and automated stuff. The ones that we really like to talk about are Street View is the really big example. We read numbers off of street signs. We match templates and spot street signs. You can actually see a no left turn in some countries is always the same shape, and so you can spot those automatically. There's also instances where Yeah, we can confirm street names. I had one other, and it just slipped my mind. But yeah, it's varied. There's a wide variety of them.
Oh, okay. Thank you.
I was just wondering about how many people do you have working on Google Maps fitting it themselves?
Work on, sorry?
How many people work on the Google Maps themselves?
The operators?
How many operators are there? Yes.
Yeah, so we don't like to talk about the exact size of the workforce. We do say, though, it takes hundreds of people to map the typical country. So it's a very large-scale effort.
Yeah, thank you.
Hi, and please correct me if this is going to be addressed elsewhere in the conference. But I have a question about public transit data, and in particular, sort of, are you guys incorporating real-time, live transit data into your directions?
Yeah, so I'm not an expert on this, but the two forms of transit data that I'm aware of, we have a data format that's public.
Yes, GTFS.
Yes, and so people can publish the basic static transit info. And I do know that we serve live transit info, ETAs for trains and where is the current train, things like that, for a select number of cities. I don't know how many, and I'm not sure of exactly how that works, though.
G'day. My company uses a lot of Google Maps stuff, and I'm just wondering, is there any way that users can put in colloquial names for places, or is there any...
Sorry, put in what?
Colloquial names for
Colloquial.
places, so Joe's Pub, or...
Does MapMaker support that?
MapMaker does support that.
Yeah, so there's a whole schema and set of classifications for how you name things, whether it's a city or a road, and we model that in intricate detail, and you flag something as, its local name, its obscure name that maybe we shouldn't show, but we should show in response to searches. All that, we have modeling internally for that, and much of it is reflected on MapMaker, so you can directly edit that data.
What's the process to upload that to you guys?
We don't have a method right now for a mass upload. It would be for individual corrections.
Okay, cool.
Hi, I was wondering, how do you deal with updates to the mapping data, new projects, new roads, or roads get blocked, or is there a process that you guys follow for that?
It's the things that I outlined, basically. We mostly rely on users. Users are very proactive and actually wind up alerting to us about most things. The Crystal Ball report is really good, particularly for large changes, even before they happen. We'll find out that a freeway interchange construction is going to finish, and we might be able to open it on maps the same day that it opens in the real world. And then we do these redrives and reflies of imagery, and we revisit things that we weren't completely sure about before.
All right. Thank you.
Yeah, one of my questions was around the date timing of things, like if an interchange is about to open or a bridge construction or something like that. Is it date stamped, like where you can release a new version of the map on a particular day?
So the way that our systems work, we don't actually model, say, it's going to open in 2 weeks. There's no way in MapMaker to mark that. But we have the ability for big changes to kind of synchronize and make sure that we push it out at the right time. We're republishing continuously. It's actually not even as simple as saying that, we're currently running a map that was created a week ago, because It's literally moment by moment there's users interacting with it.
Yeah, so that kind of brings up my next one. Like, you've got incidents or events with traffic data, right? Is there any way to tie that to longer term events like construction, road closures, that kind of stuff?
Tie it to it as far as what?
Like if a lane is going to be closed for 2 weeks or a month or a year, that kind of stuff, where bridge construction or
Yeah, so we have some guidelines internally where if something's going to go on for more than a certain period of time, we turn it into an actual map data change. If it's really transient in nature, it shows up on the traffic layer as like a little warning sign or something, but we don't modify the data itself.
Okay, thanks.
Hey, just a question on business data in less developed countries. So things like knowing the names of businesses and their GPS locations. I know, I used to live in Indonesia, and you were just saying you recently did ground truth for there, but I mean, how do you do the business part of it?
Yeah, so we haven't talked a lot about what we call local data, which is business listings. Map data is a piece of cake compared to local data. Particularly in some countries like Indonesia, it can be a challenge. And there's no one answer. We go into a country and we source whatever we can, and in some countries that's pretty high quality, in other countries it's a little lower. But we also rely on users a lot. India is pretty much exclusively mapped by its users. It's a surprisingly well-mapped country, given that starting point. in many places. So users are actually taking ownership of whole neighborhoods and curating the businesses there. So there's different strategies for different places.
So sort of related to that, you mentioned that sometimes you prefer user-submitted maps over Project Ground Truth or some of the other things you do, and I'm curious why that would be the case.
Yeah, if I use the word prefer, that's probably a strong word.
Okay.
Ground truth is very expensive and difficult and takes a lot of time. It's going to take us a while to map the countries that we do want to map. And we just make careful trade-offs and try to figure out what's the best way to bring something to market to users quickest. And in the case of India, we started MapMaker there in 2008, 2009. One of those two. And so it got a huge jump start, long before we would have been able to address it with ground truth.
Hi, I'm Eric, and I was wondering if you guys were going to do parking, because I see you guys are able to pull like business logos, and you guys obviously have a lot of city data as well. And obviously when we drive anywhere, that's a big part of what our actual destination is.
Yeah, I mean, parking information is something of interest to us. Ultimately, we basically want to model the entirety of the real world on the map. It should be possible for you to answer any question that has a place, using the map.
So following up on India, you mentioned that you rely entirely or almost entirely on user-submitted mapping in other countries as well. So it's my understanding that this is entirely a closed system. So do you ever give back? I mean, it's kind of like users are sort of doing your business for you. Do you ever give back to them, or are they just sort of contributing for free?
Yeah, so we do in a number of countries actually give back. I don't remember if India is one of them or not, but there's a list of countries that have humanitarian needs that we make the data available to NGOs free of charge. It is the case that you can't directly download the data. We've taken the approach that we believe that this type of ecosystem is going to be the most effective. If they download it and they try to fork it or they try to modify it, it's unclear what you'd want to do with it. Additionally, we really feel that the Maps API is sort of the optimal way to leverage the geodata. So we do want to enhance the API over time to do anything that you'd want to do by downloading the data.
So my question is related to ground truth data for indoor maps. So like if I get it correctly, right now they are focusing on users to give indoor maps information. So what's your thought about like having, like you have self-driven cars for outdoor environments, like something like that close to a robot to go around, collect the data for you for ground truth information?
So you're asking if we are going to make robots to roam the airports and map them in interior?
Yeah, or like self-driven cars indoors, which would help you.
I think that's a great idea, and you should go track down Larry or Sergey and apply for a job at Google X. It's a hard problem, and it's also a scaling problem and questions of logistics of is it easier to put humans there, is it easier to put robots there, and who would be better at it?
But I guess like the sensors they've been using right now are just Wi-Fi. So like if you had sensor information from cameras and stuff like with visual information, it would be easier to map those locations. So do you have any sensor inputs from the users that they could give for visual information?
That's conceivable. It's an interesting idea, and it's not far off from Brian in the keynote. He showed that interior 3D photo tour. And there's a lot of information being constructed there about the interior of a famous place. So it's an interesting idea.
And this does give us a chance to pitch a talk that's occurring tomorrow on localization. We're incredibly agnostic about what we use in far of sensors and technologies. So we'll try anything.
Do you know the title of the talk?
No, but it might have localization in it.
Okay.
Yeah.
If you can find me afterward, I'll make sure. Okay.
Internationalization and localization? Something
No,
like
it's
that?
localization in the spatial sense.
Yeah.
Okay, all right.
If you can find us afterward, we'll give you the information.
Thanks a lot. Yeah.
Hi. As some of you guys might know, there's another project that's doing a lot of this, OpenStreetMap. And I'm wondering if you could talk a little bit about your relationship with them, and has that changed at all?
Yeah. I and virtually everybody in Google Maps are huge fans of OpenStreetMap. I think it's a really cool project. To date, we haven't worked very closely with them. We've supported them in the past with some funds or something, but they have a very different approach. They're doing a very open approach. We are, as was commented, it's a more closed ecosystem, but competition is awesome. We can see, and it's not a zero-sum game, as Larry was saying, and it's not a win-all or take-all, because in some places one model might work better, in some places others will. So we'll just have to see.
Thanks.
With 30 seconds left, maybe last question.
Yeah.
How do you report a problem which is not specific to a location, but probably a wrong algorithm?
Probably wrong.
A wrong algorithm.
Can you give an example?
In my city, if you look for streets and you don't specify the first name of the person of the street, you don't find the result.
You should come talk to us.
Right, so come find us
Yeah.
after. But a larger answer to that is we accept incredibly general input on RMI.
And I think it happened when the ground truth was introduced last year.
It's hard to get everything exactly right. But as Andrew was saying, if you report a problem, even if it's general, it does flow into a larger bucketing system, and we address all scale of complaints. So I think we're out of time. Thanks, everybody, again for coming.